This is chapter 4.5, using the converse of the Pythagorean theorem to classify triangles. You know from the Pythagorean theorem that a right triangle is a squared plus b squared equals c squared. However, you can also determine whether a triangle is acute or obtuse, because when a squared plus b squared, those are the two shorter sides, is greater than c squared, the longest side, then it will be acute. Likewise, when a squared plus b squared, the two shorter sides, are less than c squared, the longest side, then it will be an obtuse triangle. Again, don't forget that a and b are the shorter sides, and c is the longest side. Now, when you look at this triangle, let's call this letter A, it has shorter sides of 9 and 7 and a longer side of 11. You can look at the picture and know it's an acute triangle, but here's how you prove it mathematically. You take the shorter side 9 squared plus the other shorter side 7 squared, and it's going to equal the longer side squared, 11 squared. 9 squared is 81, 4 squared is 49, 11 squared is 121. If you do 80 and 40, you get 120. 1 and 9 is 10. 120 and 10 is 130. And 130, let's put a question mark above these because we don't know if they're going to equal or not. So 130 is going to be greater than 121. And if you look back, if your sum of your two shorter sides squared is greater than c squared, it is an acute, let's change the color here, acute triangle. We mathematically proved that it was an acute triangle. Now let's take a look at an obtuse triangle. Here's an obtuse triangle, and you can see it from the picture, but you need to prove it. So you take your two shorter sides, 5 and 2, and square them. 2 squared plus 5 squared, add them together, and they're going to be either equal to, greater than, or less than, it should be less than, because it looks obtuse, 6 squared, the longest side. So 4, 2 squared, plus 5 squared is 25. We're wondering what will go here, greater than, less than, or equal to, and 6 squared is 36. 4 and 25 is 29, and 29 is less than, the sum of the two shorter sides is less than 36, which means that it's going to be an obtuse triangle. Make sure you put triangle because we're not talking about angles. And you can see if it's less than, it's going to be obtuse. Let's go ahead and highlight the key idea here. That's the greater than, less than is what's going to help you know this. You're pretty good with the equal to, so I don't think we need to really do one of those. But we will do one, and then I'll do one where it's a little more challenging, meaning your sides are not going to be an integer value. Okay, so this looks like a right triangle, so it probably will be, but we still need to prove it mathematically. So we have 9 squared, shorter side, plus 12 squared, shorter side, is something compared to the longest side, which is 15 squared. 9 squared is 81, 12 squared is 144, and 15 squared is 225. So we're going to add up 81 and 144. I would just tell you to go like 14 and 8. 14 and 8 is 22, so 220. And then 1 and 4, adding from the front again, is 5, so 220 plus 5 is 225. Oops, these should be question marks. But at this point, we know 225 is equal to 225. That is your key. Right here is this equal. So that means that, in fact, this is a right. And don't just put right, you need to put triangle. Because there are right angles and there are right triangles. Okay, so now we're going to do one that's a little more challenging with the picture, and then we'll go without the picture. This is letter D, and we're going to go ahead and do this one here. Okay, one of the sides is 5, the other is 4, and then this one is the square root of 35. Well, you need to think about that for just a moment, because a lot of you don't know what the square root of 35 is, but the square root of 35 is really close to the square root of 36. And the square root of 36 equals 6. So this is definitely the longest side, the square root of 35. So you're going to have 5 squared plus 4 squared is what? equal sign with a question mark, square root of 35 squared. You're not always going to have a side that equals an integer value like 5 and 4. But before we do that, let's come down and let's look at a little pattern here. So if I had the square root of 4 squared, that would equal the square root of 4 times the square root of 4, which equals the square root of 16, which equals 4. And what I'm hoping you're seeing is that there's the 4 right here, and here's a 4 right here. Likewise, if I had the square root of 3 squared, we're doing nice easy numbers so you can see the pattern. That would be the square root of 3 times the square root of 3, which equals the square root of 9. Square root of 9 is 3. And so what I'm hoping you will see is that this and this match. Let's do one that's a little bit bigger. Go back to this. Square root of 81 squared. Now you would want to do a calculator for this. Square root of 81 times the square root of 81. So we'll give you that amount. So the square root of 81 squared was the square root of 81 times the square root of 81, which when you put it in the calculator gives you the square root of 6,561. When you take the square root of 6,561, which is a perfect square, you get 81. And again, what I'm hoping you're seeing is that these numbers match. Whenever you square a square root, you end up with the number that is underneath the square root symbol or under the radicand. Okay, so coming back up here, we have the square root of, this is was just a little bit of knowledge to help you save some time. 5 squared is 25, 4 squared is 16. We're looking to see whether it equals or is less than or greater than. It looks like it's going to be greater than. Square root of 35 squared is just going to be 35. It's going to be the number that is under the radical symbol. It's going to be the radicand. 25 and 16, 20 and 10 is 30. 5 and 6 is 11. So 30 and 11 is 41. 41 is in fact greater than 35, which is what we predicted it would be. It's going to be greater than. Highlight that. And when it is greater than, if you will remember back, if it is greater than, we'll go back up a page just to remind you. Greater than is going to be an acute triangle. Okay, so let's go ahead and write that. Acute triangle. All right, now we're going to go where we don't have a picture, we just have numbers. So that's our next step. Okay, for letter E, 4, 4, and 4 are the sides. Well, now you know that this is going to be, from past experience, it's going to be equilateral, which then means it's equiangular. And we know from an equiangular triangle, if all 3 interior angles equal 180 degrees, then if you divided that 180 degrees by 3, you would end up with 60 degrees. We know this is going to be an acute triangle, but we need to prove it mathematically using the converse of the Pythagorean theorem. So let's go ahead and do that. So you're going to have the 2 shorter sides. There are no shorter sides. They're equal. 4 squared plus 4 squared is what compared to 4 squared. And we've got 16 plus 16 is what compared to 16. And 32, 16 plus 16, is in fact greater than 16. And if you remember from the first page, that anytime you have the 2 shorter sides being greater than the longest side, it is going to be an acute triangle. And again, make sure you put the word triangle on there. Okay, letter F. Okay, so we take a look at letter F. We've got a triangle that has sides of 16, 30, and 36. 16 and 30 are the shortest sides, so 16 squared plus 30 squared is what compared to 36 squared, which is the longest side. 16 squared is 256. 30 squared, now that one you can do mentally. Probably you'd want to do 16 squared on the calculator. 3 times 3 is 9, so 30 times 30, add on 2 zeros, is 900, is what compared to. Now 36 squared, 36 times 36, you're going to want to do on the calculator. That's 1,296. So we add 900 plus 256, and we get 1156. You could have done that mentally. If this were 1,000, 1,000 and 256 would be 1,256, but since it's 100 less, we go 1,156 is less than 1,296. And if you remember back, if it is less than, just like this was greater than, and it gave you a cute, if it's less than, then it's going to be an obtuse triangle. Okay, I want you to just do a quick review, see if you can do it without looking at your book, and then turn the recording back on to see if you got it right. Because we really want to make sure that you remember the pattern for the converse of the Pythagorean theorem. Again, this is kind of the whole thing that you're looking at, is that pattern of the converse of the Pythagorean theorem in order to classify. So you're using the converse of the Pythagorean theorem in order to classify triangles. All right, so let's go ahead and take a minute to look at this. So mentally, would you fill this in? For a right triangle, a squared plus b squared is what compared to c squared? For an acute triangle, a squared plus b squared is what compared to c squared? And for an obtuse triangle, a squared plus b squared is what compared to c squared? Go ahead and mentally do that, and then turn the recording on to see how you did. Remember, a and b are the shorter sides, c is the longest side. For a right triangle, a squared plus b squared will be equal to c squared. For an acute triangle, a squared plus b squared will be greater than c squared. And for an obtuse triangle, a squared plus b squared will be less than c squared. Hopefully this recording has been helpful to you. You can always go back and rewatch the parts that you need to help you complete your assignment or study for quizzes and tests.